Good morning, everyone. Welcome to another episode of XahTV Talk Show. Today is 2021, June 2nd, and today we are going to do wolfram language, Mathematica tutorial, wolfram language, okay? I'm going to give you a basic tutorial of wolfram language from the ground up. And so you can see here on my screen, I have my Python tutorial, Python 3 in 1 hour. That covers the most basic things. For example, how you do string, how you do substring, string methods, arithmetics, plus, minus, divide, multiply, quotient, and how you do assignment operators, and true and false. What is true? What is Boolean? Boolean values, and condition, if then else loop, and so on. So this tutorial and list, then we get on to data structures. List in Python, you have list, tuple, then you have sequence types, then you have dictionary, which is a hash table, key value pairs. Then how do you loop? How do you do loop through hash tables or list? Then you have writing a module, loading a library. Then how do you define a function? Then how do you define a class and object in Python? And how do you write a module? So that is the basic structure. Basically, every programming language has this kind of thing. Basic structure of learning a language, what you need to know. So that's Python 3 in 1 hour. So if you like my stuff, check it out. Okay, just search for XahTV Python tutorial. Then I also have a JavaScript in-depth tutorial. And for example, let's go to JavaScript basics. It's basically the same thing. How do you run JavaScript? What's a common syntax? How do you print stuff? Then you have strings. How do you do strings? Then string, substring, join string, string length, string methods, arithmetics, assignment, number, and so on. And then start variables, data types, list, Boolean, and the same thing. So today I'm going to do the same thing. I'm going to actually write one for Mathematica, for wolfram language. Okay, I'm gonna start to write one. So let's start. So let's base it on JavaScript. Okay, I mean based on my Python tutorial. So let's begin. If you have questions, comments, post it. Okay. Related to programming or Mathematica. Okay, let's make it focus on that today. Hey, good morning, Emily. Fantastic, great to see you, Emily. The most technical people in our group. And good morning, Lucas Sambi, and good morning, Sid Ali. Hi, guys. So let's begin Mathematica. So let's see. Let me show you. Okay, so Mathematica. Let's start Mathematica. 3 plus 2. Okay. 3 plus 2, what is the, you have to press shift enter, but I have a shortcut key. Yeah, let's forget about that. Okay, so let's magnify the screen so you can actually see better. Okay, so Mathematica, so we're gonna start to cover that today. So how do you do strings? Strings is basically the same thing. This is a string. So string is done by curly quotes. I mean double straight quotes. Okay, I need to find my key for Mathematica enter. Okay, hold on a second. Let me show, let me find my shortcut for shift enter. Let me explain what's that about. Oh, okay, that key. Okay, so shift enter. So in Mathematica, so for example, 3 plus 3. Okay, so if you press enter, it's just going to add return. So if you want to evaluate this part, you have to press shift enter. So I do have a shortcut, which is this key. Yeah. So okay, so we covered string. So let's start to write our documentation. Okay, so first of all, so you are also looking at my Emacs workflow. So let's cover strings. Okay, some of the major topics. So we're gonna cover strings. So what else we're gonna cover? Let's see. We're gonna cover strings, string joins, string length, string functions in general. How do you manipulate strings in Mathematica? Okay. Then arithmetics. Okay. Okay, we're gonna cover that. Then we have convert to int float. You don't have that issues with Mathematica. Assignment, okay, so assignments. Okay, then you have, we're gonna cover assignments and true and false. True and false in wolfram language, and conditional if then else, okay? If then. Okay, then loop iteration, okay, then loop. Okay, then we're gonna cover list. Okay, list. Mathematica wolfram language is a, you could say it's a family of the Lisp language. So that means everything, the entire language is based on list. List is the most fundamental data structure. You don't have things like tuple. They added hash value in the past few years, but we can ignore that for now. But anyway, let me continue. So then we're gonna cover, let's skip that. So I'm gonna cover the most fundamental. So after watching this video, you'll be able to program Mathematica. So loop through list dictionary. So okay, so then loop through list. How do you iterate? Going through the list, and how do you take and list operations? Okay, list operations. Parts, slice, conditional, extract. Okay, extract element. Okay, when you have a list, you have several operations. For example, you want the first element, you want the sub list from a list. You want a nested list. You want so list. So let's also cover nested list. So again, wolfram language is like list. So list is in the whole entire language is a list. Okay, the entire language is a list. Actually, I can show you. Okay, so, and this is the most fundamental data structure, essentially the only data structure in wolfram language. They have others, but basically this is the only data structure. So everything is a list. So when it comes to list, operations on list, there's tons of them. Tens of them operations on list, because the wolfram language, just like list, they focus on the idea where you only have one single data structure. Then all your functions can all work on that data structure. So you have combinatorial power, flexibility. So because every function works on a list, so then you can, you can compose those functions. So you have the most powerful functions to operate on the data. So this is one of the primary fundamental idea or the advantage of functional programming. So this in contrast to object-oriented programming. In object-oriented programming, every data is one type, because that's what classes are. When you have a data type, a number, then you have a bunch of functions that just only work for numbers. When you have a string, then you have a bunch of functions that only works for string. They don't mesh, okay? But each one becomes an object by itself with with a set, bundled box of functions that works on that data type. So this is the object-oriented programming philosophy, where you have 1,000 data. Each data is bundled with a bunch of functions, 1,000 data types. On the other hand, functional programming is the kind of the extreme contrast. You only have one data type in general, okay? In general, then all your functions all work on that data type. Then you can compose your functions to do to get what you want. Okay, so that's a basic idea, the contrast philosophy of object-oriented programming versus functional. So list is the most fundamental data type in wolfram language. Okay, then I'm gonna talk about. Okay, so what else to talk about? Then define a function. Okay, function. Okay. Then define a function, and you don't have class and object in wolfram language. Those are foreign things. You could write them, but that's not the fundamental core idea. Writing a module, that's more advanced. We can skip today. So we're gonna cover these topics today. Okay, time is tight. I need to go fast. Hello, Jason. Hello, Justine. Hello, Justine. So let's begin. Okay, one more check. Am I alive? Yes, alive and kicking. Okay, strings. Okay, so we already did strings. Okay, string. Let's copy. Okay, so let's write the tutorial on the fly. String is quoted by double straight quote. Okay, so wolfram okay. Okay, so we have an example. That's a string. Okay, string, join string, string length, string functions. Okay, join string. Join string is done by let's paste a lot of these things, so we have save our time. Templates. So how do you join string? Okay, join string is when you program in Python, Perl, Ruby, PHP, all these languages, scripting languages, string is one of the most fundamental data type, because you work with strings all the time. Text processing, Perl, Python, PHP, and JavaScript, almost all the language, even Golang, even C. String is one of the most fundamental type, because you do text processing, you manipulate strings or byte sequences. That's not the case in Mathematica, in Wolfram language, because Wolfram language is not a language designed, originally created to do strings. Wolfram language is originally designed to do mathematics, computation, symbolic computation. So, but however, the string functions, it's more powerful. I would claim it's more powerful than any of the Perl, Python, Ruby. Okay, the string functions, it's more powerful, but it's not so often used. Okay, so join string, this is a function. Okay, let me just join string. Okay, now string join is a function. Now there is a shortcut key to enter the whole template. I wanted to do that. So here's the documentation. Join string join. You can search for that Wolfram documentation. It's exactly the same thing you'll see on their website. So string join. Now there is a shortcut. I don't remember anyway. Let's not waste time. So let's ABC. Okay, so string join, you can do it this way. ABCD. Okay, so enter. So that's string join. Okay, copy that. Okay, we got join string, and there are many syntax shortcuts I talked about in one of my last video about Wolfram language, a systematic syntax shortcut. So you should go watch that. So for example, the join string, you can also write in this way. Okay, AB then that CD. Okay, so you see you got ABCD. It's the same thing. And so that's a syntactical shortcut. Okay, and there's also also in general, you can also do it this way. Tilde, then the function name, then tilde, then CD. Okay, so this is the most general. So look at this syntax. Okay, this is the most general infix syntax for any function. Now Wolfram language has about 6,000 functions out of the box, all built-in. So it's unlike other languages where you have to load libraries. By default, you only have 10 libraries or 20 functions, 50 functions built in. Then you have to load libraries for reading files, for reading directories, for load libraries. Typically in all these industrial languages, Wolfram language is very different. Out of the box, like right now, I have 6,000 functions. Let's see. Let's show you. Okay, what is that? So let me show you. I'm not sure what is that. I want to enter the asterisk. Okay, so So out of the box, you can see incomplete expression. Okay, hold on a second. Okay, it's returning, basically right now it's returning 6,000 functions, okay? You see, you no need to load libraries. Okay, we need to delete that. This is too much. So how do you get? Let's skip that. Okay. Anyway, 6,000 functions. Okay. So okay, string, join string. So how do you get substring? Okay, substring. String part. Okay, string part is a function to get a substring. So for example, string part ABCD E. Okay, then let's say the third character. Okay, that's how you get substring. Copy that, paste it. Okay, show in browser. Okay, string substring. String join string length. Okay, now length is just length. Okay. Now another thing you'll notice in wolfram language, every function have the form function name and square bracket then argument. The whole language, literally every function is of the form. So you don't have to use the plus sign if you don't want to. For example, if you want to do 3 plus 2, you can say plus 3 2. Okay, again, in my previous video, I covered this in detail. A systematic syntactic layer. So the 6,000 functions all have this form, function name, square bracket, arguments. And then you have shortcuts such as things like that, or things like plus, minus sign, or the curly quote for list and so on. So anyway, so length, let's cover length, ABCD, okay? Okay, you have to say string length. Yeah, string length, not length, okay? ABC, okay? So string length is how you get the length of a string. Let's put it here, string length. Okay, I think that's enough about string. Let's move on, okay? Then string functions, okay? What about string functions? So here is how you do it. What about all the string functions? You type that, then here's all the string functions, okay? So you have so actually I want to get a list. I don't want this user interface kind of thing. I want a list. So so anyway, this is one of the way to, it's kind of like a help system, but there is actually a form. I believe it's help. I don't remember what. Okay, let me go. Hold on a second. Let me. Anyway, so we are talking about string functions. So you are seeing the 20 or so, the 30 or so string built-in string functions. For example, so let's go through some of them. String byte count, string cases return, extract certain strings. Okay, if you want string contains Q, that means if you want to know if a string contains some substring. Now all wolfram language that are predicate has the convention, the function name ends in Q, capital Q. Q means question, okay? So string Q means whether the argument is a string type. So string part returns the part of the substring. We covered that. For example, string contains Q. You click that. You see the documentation. Then you can click this I symbol to go to the full detailed documentation. So string contains Q to test if a string contains some substring. Then you have string extract, string ends Q, string drop. You want to delete part of the string. String format, string free, string insert, string join, string length, string match Q, and you string split. For example, string split that turns a string into a list. Yeah, so that's about string functions. Okay, so string methods. Okay, let me show the, okay, to get a list. Okay, hold on a second. To get a list of all string functions, type question mark string question marks string asterisk. Okay, showing browser. So there we have it. Okay, so that's string functions. So we are done with string. So let's move on. So let's string join. Okay, so string join, string length. Let's just say string functions. Okay, so here is the string functions section. We covered that. Okay, showing browser. Perfect. Now arithmetics. Now arithmetic is super easy. Okay, so 1 plus 3 plus 2, addition 3 minus 2. That's okay. 3 minus 3 is 1. 3 plus 3 multiplied by 2. 3 divided by 2. Okay. Now it returns a fraction. Now this is interesting. Now remember, Mathematica is symbolic. That means every result, whatever you compute, by default, the result is symbolic. So it doesn't return, if you do 3 divided by 2, it doesn't say, you cannot divide integers with a float. Or it doesn't return just a quotient, like 1, remainder 1. The symbolic result of 3 divided by 2 is the fraction, 3 over 2. Now, if you want a numerical result, you use the function n, okay? So n, 3 over 2 is 1.5. Or if you already have, if one of your input is an approximate number, such as 2 point something, then the result is automatically also approximate. Okay, so but just remember, by default, everything is symbolic. So arithmetic. Okay, I don't want to, I don't need to type that. So you get that. So what about other arithmetic functions? For example, modular arithmetics, get the remainder or the exponential. Okay, 3 exponential is, with the correct. Okay, so what else? And the sine cosine, sine cosine is very simple. So sine 1, so sine pi is 0, so pi is symbolic, so the value of pi is symbolic here. So you can see, so if I type pi, it returns pi because pi is a symbolic representation of pi. So if you want numerical result, you say n pi. Okay, so that gives you numerical result. Or you can say to 100 decimal places. Okay, and you can say 1 million, 10 million decimal places. Right away, it gives you the result. Okay, so this is a huge number. Okay, so we need to delete that. So this is pi to 10 million places or something. Okay, too much. Let's just say 100. Okay, so again, this n is very frequently used function. Whenever you want numerical result, you just slap an n to the whole thing, and it will. And then you can. The first argument is any expression, any complex 1,000 lines expression. The second argument is a number of decimal places you want. Okay, so it's one of the, this shows, this function, this expression illustrates one of the kind of philosophy and nature of Wolfram language. That is, it automates everything. So you don't have to worry about how you get, computation or things like that. You don't have to worry. Basically, you don't have to worry about what is int, float, double, long, whether your data, what exactly it is, or machine, or you don't have those kind of thing. It's designed. The philosophy is that it does computation. It figure out how to do things. Okay, all you are concerned as a programmer is how do you get the results. I'm a scientist, I'm a researcher in physics, in mathematics, in engineering. You want the heat flow of some space shuttle. You want to know the result, okay? Differential equation solutions, you just type it, Mathematica, give you the solution, okay? That's how most people use wolfram language anyway, as a fantastic graphing calculator. But right now, what I'm teaching you is the actual programming wolfram language, okay? So like I'm covering the industrial programmers, their idea of what's programming, the manipulate the things. So these are all the basics, okay? So we cover that. So arithmetics, I'm not going to type it now. So let's do assignment, okay? So let's move on to assignment. So assignment is, again, very simple. X equals to 4, okay? So this is assignment. You don't have to worry about declaration, declaring variables or declaring types. There's no traditional sense of types in wolfram language, okay? In traditional language, you have int, float, string. Those are data types, or list, array, or tuple, things like that. In wolfram language, you don't really have types. Variable, you don't. Okay, so it's you say it's a dynamic language. Dynamically typed language. You don't need to worry about types, and you can reassign. You can reassign variables. Okay. But value has a type. Okay, so 3 is a type. So is there a type function? So let me let me type this, okay? In general, there's no type, okay? So let me just go on to tell you what to tell you the gist of wolfram language philosophy, so you know much better instead of getting bogged down by technicalities. So wolfram language, so you don't have types. So but value has types. The type of a value is based on mathematics, okay? It's not based on implementing a compiler or int, float, long, double. What's that? What the fuck is that? It's based on mathematics. So there's no distinction between integers and float. That's compiler idiocy. But there is a distinction between integers and real numbers. Okay, now that's a mathematical distinction, math idea. Integers versus real numbers. Okay. So for example, pi is a real number. So let me show you, okay? Real Q, is there a thing? So what is real? So let's see. Real is a head used for real floating numbers. So okay, so that kind of indicate. Okay, that kind of indicates my sense, what I'm trying to say. So you have this function. Okay, this is getting more advanced. So real is the head used for real floating numbers. Okay, I'm not going to explain that, but basically what I'm saying is that so wolfram language distinguish the type of values. And what are the type of values? The concept of type is based on mathematics. So there's integers, there is real numbers, and there's complex numbers. Okay, that's the essential values type. Then you have booleans, okay? Then you also do have booleans, okay? Boolean type. Then you have string type. Then you have list, okay? Okay, that's the type. In contrast, what you do not have is you don't have reference. You don't have reference type. You don't have pointer type. You don't have int versus float, double. Those kind of thing. You don't have something that's inconsequential to a programmer. That's a byproduct of compilers, of CPU, of implementation details. You don't have those concepts. Okay, so let's move on. So arithmetics, assignment, okay, and variables. Okay, so variables. Let's talk about variables. So assignment and variables. Okay. Okay, so we have seen, so these variables, x equals 4, those are global variables. Now, if you want local variables, you do this, okay? This might seem odd, but the name might seem odd to you, but that's how you do, okay? So, for example, we defined x before. So if we type x, it's 5. Now, you can say module, okay? So module x equals to, let's say x equals to 3. Okay, then you can do some computation. Okay, then you can say x squared. Okay, so that will return 9. 3 times 9, 3 times 3 is 9. Okay, so for example, let's do it, 9. So this is how you do local variables. So here you declare the variable x as a local variable. Then anything inside this part is just local. Okay. For example, now if you say x, it's still 5. So this is a local variable. This is how you define local variable. So let me copy that. Local var. Okay. Do it by. Let me type that. So module xy ... and okay. So let me then let me type the whole thing. So you are looking at my Emacs workflow. Okay. Show in browser. So variables. Okay, so variables, local variable, do it by this form, module, curly quote, variable names, then expression. The expression can be a compound expression. So here's an actual example. So that's and this variable, the scope of this variable is lexical. Okay, so this is a lexical. Now, for those of you more advanced, lexical scope. Let me write it. Okay. Now you also have dynamic scope. Okay, if you want dynamic scope, you say block. Okay, so just like module, but except you use the word block. Okay, so I'm not going to cover that. Basically, you always want to use module, lexical variable. Okay, so let's cover true and false. Now, hold on a second. Let me read the comments. And how long have I been talking? 33 minutes. Okay, so actually, we're doing not bad. Okay, so does the wolfram language have named tuples? No, it doesn't. Hey, Daniel Langlois, I'm kidding. I want to start to rant, on tangent about the design, yeah. So wolfram language, everything is based on. Okay, let's not begin that. So Luca Sambi says Mathematica seems to be one of the easiest programming language, indeed, but however, it has a reputation of being difficult because it's unusual. Let's put it this way. Okay, so if you are a beginner programmer, you can learn many languages, among Python, Perl, Ruby, C, C++, C#, Java, JavaScript, or you can learn wolfram language. Okay. Now, if you are a beginning programmer, you're gonna spend, let's say, half a year, let's say 1 month learning the language. Which one would be easiest? I would say wolfram language would be the easiest. But however, that's not a common perception to industrial programmers. Why? Because industrial programmers, you are used to, you are all your surroundings, all the colleagues, co-workers at all the big companies, C++, Perl, Python, Java, Ruby, and Bash, they are all of the same class. Like they are all talking about int, float, declaration of types. So they are very different. So when in that context, so to them, wolfram language is foreign, So when if you are a typical C, you came from C or Java or Ruby, Python, you'll find, oh, this is strange. How you might get that sense. So anyway, it's going to get complex. Okay, we are covering the basics, but then later on you'll see the symbolic nature of wolfram language. Then it can start to get very complex. You are when you start to do pattern matching, symbolic computation. So, but let's go on with the basics, okay? Yeah, let's continue with the basics. So we covered module. So so local variables. Then let's do true and false. So what is true and false? Now, true and false in wolfram language, there are only two values, literal expressions for true and false. Okay, one is this capital case true. Okay, and the other one is false. Now, not lowercase, it must be capital. These are built-in symbols. True and false are built-in symbols. Okay, so when you have an expression, so this starting to get interesting about the symbolic nature of wolfram language. In many other languages, okay, in Python, for example. So, you have a built-in literal true and false. In the case of Python, it's exactly the same as wolfram language. Capital letter true and false. But then, if you have a if statement, then if you have a value that's not either the built-in symbol true and false, what happens? Well, in many languages, they just have this kind of ad hoc way. So if you have number 0, then that's considered false. If you have a float 0, that's also false. If you have empty string, empty list, empty tuple, that's also considered false in Python. Okay, in Perl, Ruby, it's different. Okay, they basically all industrial languages are like that. They have an ad hoc way to decide what is true and false. And in Emacs Lisp, it's the same. In Emacs Lisp, the only thing is false is nil and empty list. Everything else is true. So anyway, in all these languages, their way to decide what is true and false of an expression is just basically ad hoc. Every language is different. Now in wolfram language, it's a bit different. Okay, so when you have an expression, so let me show you how to do if. Okay, so let's say if 3 greater than 2. So if it's true, let's say you want to return yes. Okay, let's say string yes. If it's false, you say no. Okay, so this is how you do if statement. Okay, evaluate it so it prints yes. Now what if you have an expression that's you have some expression x here, where x does not evaluate to the literal true and false value. What does wolfram language do? It returns the expression unchanged. So that's what it returns. So when something is considered true, only if it's the literal value true. Okay. And or it'll be considered false if it is only literal value false. If it's not true or false, then it returns the thing unchanged. Okay, that's kind of the important thing to know. That's a practical thing. So if you want an if statement to actually evaluate to something else, to get a result, you have to make sure that your test, it actually returns one of these true or false. Okay, so anyway, that's how you do if. Okay, let me copy that, paste it here. Okay, so show in browser. So we have if then. So okay, but what about other conditionals? Okay, I don't use you don't need it, you don't use it much, but let me show you. Now let me show you how do you in general find out certain functions. So right now we want to know what are the other conditional expressions. By the way, in wolfram language, just like other functional programming languages, everything is an expression. There's no statements. Okay, so this if is a expression, it so it takes 3 arguments. The first one is a test, then the second expression is returned if evaluates to true, otherwise the the third expression. So this if expression returns a value. So for example, let me do some more let's start to do some compound computation. Okay, so for example, 3 else 2, then let's say plus 2. Okay, so you can actually evaluate that. Let's say plus 20. So everything is expression. That means you can combine all, any part of your source code. You can just start to combine them. Okay, so that's one of the advantage or the philosophy of functional programming. Everything is an expression. Any part of in your source code, you can grab the unit, you can mix, and you can place, move it to anywhere. Everything is an expression. So this if expression is analogous to C languages, so-called ternary expression, which is, I'm digressing, but which is question mark, true statement, so that's the, that's a ternary expression in C-like languages, which is everywhere, a virus. So anyway, if then. So now let me digress to, so what if you want to know, so let's see, let's type if, okay? So right now we want to know all the functions that related to booleans. Okay, how do you conditional, branching construct? We want to know, or what are the others? I don't know right now. I don't remember. Basically, you just use if. Okay, so for example, is there a which? Is there a switch? Is there a conditional construct? I want to know. So how do you know that? So first of all, if you know one of them, you type that. So it gives you the documentation of the if function. Then you click the help. Okay, so you got the full documentation of the if expression. Then you go down. Usually at the bottom, you'll see C also. Okay, there it is. So these are related functions that related to this function if. So you can see there's also switch statement. Okay, here's the syntax. Now go back. There's also a which statement. Okay, basically you don't use those. Okay. Now later on, in other day, later on, in my later videos, I'll start to get more advanced in wolfram language programming. Then you'll start to know about programming styles. Which one is more suitable for wolfram language? Which one is more powerful? Certain things you just never use in wolfram language. Anyway. So here, switch is useful, and switch, basically you don't use that in general. Okay, when you program wolfram language, you don't use that. And okay, so back to, so how do you find the related function? So that's one way, C also, but here is also other important thing. Okay, so here is a tutorial. Now here is an article all about relational logical operators. So it's related. So you can find out all about related. Let's magnify. Okay. So you can find out all about. Let's magnify again. Okay. So at the bottom you can see C also and tutorials. Okay. Then everything about conditional. So click on that. So there you have it. All the conditional operators. Okay. Then and related guides. Okay, so I mean they have lots of tutorials. In a sense, my tutorial is kind of redundant, but people like to watch videos. Okay, okay, that's it. That's about that. That's how you find stuff. Oh shit. hold on a second, let me shrink my window here. Okay, so back to if then. Okay, so what about loop? Okay, so loop is an interesting topic. So first of all, I can show you. So what are the common loop constructs? So you have for loop, while loop, for loop, while loop, for each loop. These are very common loops, especially for and while, and the do. Okay, let's see how I want to cover this, because okay, so I started to, let's see, how long have I been talking? 46 minutes. I need to go faster. So any comments? No comments. Okay, am I still going? Yes. So okay, so so wolfram language supports all that, okay, but usually you don't use that. Okay, so for example, let's show you do loop. Okay, let's show you for loop. Okay, now for loop is a procedural programming construct. So here is the syntax for loop. So let me show you. Okay, for takes 4 arguments, just like C. Okay, it's modeled after C. So you start with an expression, I equals to 1, then you test. Okay, so I less than 9, then you have increment. Okay, so I plus plus, again, that's also supported in wolfram language, I plus plus, then you have body. Okay, so you can say print I. Okay, so that should work. There you have it. So that's a for loop. Okay, copy. But anyway, you never use it. Okay, so if you want to be a good wolfram language programmer, you never use this, because it's not the right style. More specifically, because it's not efficient. It's not efficient, it's cumbersome. Okay, because in wolfram language functional style, you have much more powerful and simpler and more suitable, more easier to understand, faster, simpler, and constructs to do loops. Okay, so I'm showing you this. You can start to use it, but in general you don't use it. Okay. Now also let me also mention there's also while loop. Okay. Again, it just modeled after C. Okay. So you have while loop. You also have do. Okay. So let's see do. Okay, do expression n times. This is when you know how many times you want to loop. Okay, so you have do, then you have more. Sometimes you do use do, but in general, okay, you don't use do, for, and while. So what do you use? Okay, so then we start to get into. So you in general you use. Okay, so let me start to say. Okay, so also while loop. Okay. Then you also have do loop. Okay, so let me write it. In general, you use functional program. You use functions. You use functions. You use functional programming functions for loop or iteration. Okay, so for example, let me show you. For example, okay, so for example, nest. Okay, nest list. Map table range. Let me just cover some of these. Okay, so let me cover starting from the most useful and basic first. Okay, so we want to cover in this way. Okay, table, range, map, nest list. Okay, so let's do it. So let's do range first. Okay, range is the simplest. Range is just like Python's range, okay? 3 to 100. Let's say 3 to 20, okay? So you give 3, 4, 5, 3 to 20. Then you also can add an increment in step of 2, okay? And you can also have a negative. So let's say negative 20 to 20 in step of 5, okay? Then you can also have reversed, for example, from 20 to negative 20, then in increment of negative 5. So wait, does that work? Yes. Okay. Now, note one thing to notice. These are very powerful. These are far more powerful than Python's, because you try this in Python, it won't work. Try it in your favorite language, in Ruby, PHP, it won't work. So in Mathematica, it works. Then let's try. Let's try. Let's say in a fraction. So 20 to negative 20 in the step of a fraction negative 5 over 2. Okay. There you go. You got a symbolic result. Now we start to show some of the power of symbolic computation. Let's say in the step of pi, in step of negative pi, symbolically. Okay, remember, symbolically, not approximate number pi. Okay, do it. There it is. Symbolic result. Now, if you want numerical, just again, just like I mentioned before, apply the n. So, for example, let me show you this. Okay. So you see, now if you want numerical result, you do that. Okay, so here's so that's range. Okay, that's range. Okay, so I need to add some of the examples to my tutorial. So example of range. Okay. So there you have it. Okay, we forgot to write about true false. Okay, but anyway, loop. Where is our loop? Yeah, loop through a list. Okay. Actually, this should be loop operations. Where's list operations? Okay. So let's just say loop here. Okay. If loop. Wait. Shit. Oh, okay. Here. So. Okay. If then we have the loop operations. Now we showed range. Now what about table? Okay, table is when you need nested for loops. Okay, so table actually. So let me show you. Table is just like range. Okay, table is just like range. In fact, actually, let me just show the help document so you can see over there. So table is just like range. Okay, so the syntax is like this. The first argument is an expression, any expression. Okay. The second argument is kind of the what's called standard. How do you call this? I forgot what's. But anyway, so let me just show you. Okay. So let's say it's 3. Okay. So that means x goes 1, 2, 3. So let's say 3 to 10. Let's say 3 to 10. Okay. So this means x goes from 3 to 10 in increment of 1 of this expression. So you got that. So it's just like range. Okay. So again, you can have in step of 2. Okay. Then again, but the first part can be any expression. That's why it's become for example x powered. Okay. So for example, let's say square root. Okay. Let's build some complex expression. Sine x divided by pi raised to x. Okay, sine x divided by pi over x. X go from 3 to 10 instead of step of 2. Okay, so you got that. And if you want symbolic result, if you want numerical result, n. Okay, so n. Now percentage sign stand for the last expression, so you can do. So there is a numerical result. Okay, so that's the simplest use of table. Okay, so let's copy that. Okay. okay, so okay, now let me show you. Table takes more than one argument, more than two arguments. So let me show you. Okay, so table, table. Let's start simple. Okay, let's just say sign. Okay, sign. Let's say 1, 2, 1, 2, 3. X goes from 1 to 3. Let's say sign x times y. X goes from 1 to 3. Y goes to let's say 7 to 9. 7, 8, 9. Okay. Enter. So you got a matrix. You got basically you got a nested matrix. Okay, let's say and let's say y goes from 7 to 90 instead steps of 10. Okay, oh actually it simplifies. Okay, so actually we don't want it to, let's say divide. Okay. Okay, so again, so it can take arbitrary number of arguments. So let's show you an example of three-dimensional matrix or four-dimensional matrix. So let's say this. Okay, let's just say a list x, y, z. So x from 1 to 3, y from 1 to 3, z from z from 1 to 3. So you got a three-dimensional matrix, and it can be four-dimensional or 10-dimensional. You know, so it's a builder. So in Python, you might call this what? What is you know how they call it in Python? I forgot at the moment. So JavaScript basic, close that. Python numpy array. No, that's not what I'm thinking. So I'm thinking the Python. Wait, I remember. I must remember the word. I must remember it. Shit, I don't remember why I'm doing video. So oh yeah, list comprehension. How can I possibly forget? So in Python, you have the construct list comprehension. Okay, so that is a construct that lets you do arbitrary nested list. Okay, that's idiotic, actually. You know, I have an article. Just search for list comprehension sucks. Search for XahTV list comprehension. That's an idiotic concept. But anyway, the purpose of list comprehension is exactly the same as Wolfram language's table function. Okay. Now, let me explain. Let me tell you why. Okay, so why this is much better. So you see, you have one consistent syntax. You know, table is a function consistent with every other function in Wolfram language, consistent, and no arbitrary. You know, like in this comprehension, all of a sudden you have a new syntax within the Python language. You know, like within the list comprehension, then you have a new syntax for something in something. You know, that for is different from the for loop for. So you are essentially you are building a little language, you know, with special syntax when you do the list comprehension. That's what list comprehension is. Okay, a specialized syntax within a language. But look at the Mathematica form. It does exactly the same. List comprehension, you know, to build a nested list. Okay, exactly same power. In fact, it's more powerful. But the syntax is not special. Everything you know about Wolfram language, the syntax applies here. So you don't have to when you use this, you have to learn a new syntax and exceptions and all that. everything is regular. So, and anything can be complex expression. For example, this list, let's square it, okay? So you can square this here. Then you can build arbitrary complex power. So let's say 2 raised to the power of 2 plus pi times e. E is the natural logarithm, the number, okay? So can you see that? Simpler to read, and much more powerful. So that's something that's about language design. That's the reason this comprehension is idiotic. They have that in Haskell too, also idiotic. Most people, they don't know that. Industrial programmers, I argued with them for 20 years. They don't understand what I'm talking about. So anyway, so here that's table. So that's an illustration of the table function for building lists, arbitrary lists. One of the most useful function in Wolfram language. Okay, so that covers loops. Okay, so that covers loops. Then you also have map. Okay, so map. So let's talk about map. So we covered list. Okay, so list is simple. We already covered it because list in Wolfram language, this is a list. Okay, so 3, 4, 5, that's a list. So let's copy that list. So what about getting part of the list? Okay, so let's say x equals to a list. Okay. So if you want the first part, this is what you do, okay? So this is the shortcut syntax. Let's see that you want the first element. So that's what you do. And the full form syntax is this, okay? Part. So you can see the documentation. It shows you the full syntax, and it also shows you the shortcut. So the first part is the expression. Then you say the element, okay? So you want part of the x expression, you want the first element, that's what you do. You want the second element, you do that. And if you want a sequence, let's say range, okay? Range 20, that means 1 to 20. Okay, so you want the 5th element to the 9th element. That's what you do. Okay, so you got 5, 6, 7, 8, 9. Okay, so that's list. So this is a syntax for list, and the part is a function to extract part of list. What about other operations? Again, like I said, Wolfram language, you have like 20 or 30 functions that operate on list. So this is the most important part of, I guess, this tutorial. So how do you find out? So what you do is like I said before, you click on okay, so you type $part, okay, enter, shift enter, then you go to the full help, then at the bottom, okay, so there are so many examples. Then you can see also first, head, last, extract, position, replace part, map add, tag, take, pad left, and a lot more. So here, so you want to go to this tutorial, okay? Manipulate element of a list, and also the tutorial, picking out pieces of algebraic expressions, getting pieces of list. So they have lots of tutorials. Let's see the first one, manipulating element of a list. Okay, so you get, so part is one of the function. Then you have vectors and matrices. Okay, so they talk about table. They talk about range. We talked about length. Okay, let's not use this one. Let's say getting pieces of list. Okay, this one. Yeah, so you have take the first n elements of a list. Then you have rest, take the nth element rest of the list. You have drop, you have most is new since few years ago. List with its last element dropped. Okay, so you have okay, so then you have testing and searching list elements. So position give you element of list. Member queue is if you want to test an element is a list. Free queue is basically the reverse. Count is the count number of times certain things appears in a list. Okay, so you have these functions. Then you have other, append, removing, modify list element. Again, all this now it's simple to understand because wolfram language, they don't have special syntax. Everything you learned so far is, like just today, you already know the entire language's syntax. You see, everything is like take the functional form. So I don't even, I don't have to demonstrate this. It's very easy to understand. Then you have combining lists, join, union, referral. Referral is new. What does referral do? Interleave element of list. Then you have list and sets, intersection, complement, subsets. Okay. So anyway, so this page, I'm going over now. This page is the most important thing you want to know. So, we cover many the basics, but wolfram language, like I said, is all about list. So if you want to master programming list in wolfram language, this part, you want to be familiar with them all. Okay, partition, go and then order, sort, ordering, it's all about manipulating lists. Okay, that's it. And last thing, let's talk about functions, and that's about it for today. Greeting spot, comprehension, list of list. Okay, okay. One more thing I'm gonna cover, and that's it for today. 1 hour and 7 minutes. Okay, one more thing. How do you define functions? Okay, so functions you just define it this way. Okay. Now, function, actually, there are many ways to define function. Because wolfram language is a pattern matching rewriting system, okay? We haven't talked about that yet. It's starting to get advanced. Pattern matching, symbolic pattern matching, okay? So in some sense, you can think of list macros, but it's like a magnitude more advanced. Symbolic pattern matching, and that mechanisms, the pattern matching, symbolic pattern matching is the heart of wolfram language. It is its computational model. In theoretical computer science, you call that rewrite system. Okay, so let's quickly show you term rewriting system. Okay, so you can go to you don't use Wolfram's math word. Okay, that's a circuist thing. Do not use Wolfram, Wolfram research website math word. That's a circuist content, lowest quality content. Okay, in fact, whenever it doesn't matter what it's whether the topic is mathematics or computer science or programming. I recommend not use Wolfram math word. So you want to go to Wikipedia is better. Okay, so Wikipedia rewriting. Okay, term rewriting system. So for example, in mathematics, computer science, and logic, rewriting covers a wide range of potentially non-deterministic methods of replacing subterms of a formula with other terms. Okay, anyway, it's called rewrite systems, and this is one of the approach of algorithm, and it's mostly useful for proving mathematics or computer algebra systems and declarative programming languages. Okay, for example, in Haskell or Camel, ML, they all have that part of it. Pattern matching. Okay, so when you talk about rewriting systems, the heart of it is pattern matching. You need to have pattern matching. So what's the difference? Let me explain. So first of all, what is pattern matching? So think of regular expression in Perl, in Python. Okay, you know regular expressions. So you have strings. You want to rewrite strings. So you want to replace part of the words or a pattern of a sequence of strings by another string. So you use regular expressions. Okay, so regular expression is for strings. Now pattern matching, the rewrite system. So regular expression is kind of, you can think of it as a rewrite system, except it only works on strings. Now, pattern matching in general, it's just not for strings. It's for source code. Okay, so wolfram language is, for example, list macros. That you can think of it also as a rewrite system, because when you have a list macro or any macro in other language or C++ template, you essentially, what you are doing is you are rewriting part of your source code. Okay, by this pattern you rewrite it. Okay, that's what rewriting is about. C++ templates or list macros. Now, of course, different languages, they have different power, and some of them sucks. But you don't call list macros or the C++ template system, you don't call them rewriting system, because they are not a system. They are just ad hoc one-time pad. One-time pad in cryptanalysis. You use it one time, one form. You just it's not systematic. But however, if you have a rewriting system where your entire programming language is based on the rewriting mechanism to do computation, then you have a rewriting system, term rewriting system. Okay, that's what Mathematica is. Okay, that's what wolfram language is. So, and it's different from Haskell's or Camel or Meta language. It's different from theirs because it's the wolfram language rewriting system is symbolic. Okay, very important, symbolic based rewriting system. It's not based on in Haskell, it's type and value based. You are manipulating symbols. In other words, you are rewriting your source code. The heart of wolfram language, the engine, most heart of it, most of it is about rewrite your source code. You keep rewriting. How does wolfram language do computation? Rewrite. You keep rewriting until the result no longer changes. That's your result. Okay, let's show an example. Okay. So I'm talking about functions. Let me just finish function. So how do you define a function in wolfram language? There are many ways. The most typical way is to use the rewrite system. So if you go to wolfram language tutorial, you'll see it. For example, I want to define function, let's say x plus 1. So we define a function fx. We want to return x plus 1. Okay, that's how you define function. So now let's call the function x2, f2, it returns 3. Okay, that's how you define a function. Now, let me tell you another way to define a function. So, how you do? You do this by this way. F equals to, let's say not f, let's say g. Let's use a different symbol. So, g equals to function, then variable x, then x plus 1. Okay. Now remember, this form looks familiar. It's just like the module we had it before. Okay. Okay. So this is how you this is the alternative way to define a function. So let's try it. So now you say g2. Okay. Enter 3. Okay. Now, so you have seen two different ways to define a function in wolfram language. Okay, one is this way, one is this way. Now the second way, this way, is a much simpler one. This function thing is basically lambda in other languages, or it's basically like Lisp's lambda. So that you don't call it lambda, you just call it function. So the first argument is a list of variables, local variables. The second argument is an expression. That's how you define a function in wolfram language. Now, what about this one? What do you do this way? This is becoming complex. What happened here is actually pattern matching. Okay, so this tells Mathematica you want to define a pattern, okay? You want to have a pattern that looks like that, okay? F square bracket, then anything inside. So you are telling Mathematica, whenever you see a form, a symbolic form, where it begins with F, then square bracket, then something, replace it by that something plus 1, okay? This is pattern matching. So, this is also how you define a function, one of the way. But actually, more precisely, you are defining a pattern matching, a rule, replacement rule. That's what this colon equal means. So let me show you the full form of this, okay? Let me show you the full form of that syntax I talked about in my previous video a month ago. You should go watch that. So let me show you the full form of this syntax. So rule delayed, okay? Rule delayed, 2 arguments. The first argument is F square bracket blank X, okay? That's a pattern. The second argument is X plus X1. So I'm telling you, this you are seeing is syntactically equivalent to that, okay? Let me double check, okay? Let's check if that's true. So you say full form, then paste that expression, okay? Oh, okay, so you have to say hold. You have to say hold, otherwise whatever this expression just get evaluated, so you don't see it. So let's do it this way. So there it is. So you can see, oh, I got something wrong. So anyway, here is the full form, okay, pattern. Okay, so let me correct it. So F should be here, should be a pattern. Okay, then okay, there it is. Okay, so here is a full form for that, for this. So I'm saying that this is actually a definition of a rule to tell Mathematica whenever you see the F something, just replace it by X plus 1. And how it works, you can understand how it works by looking at the full form, which means the full syntax of that thing. So it's first of all, it's a rule delayed function. You can see, wait, so we are missing a bracket. Wait, so we are missing a bracket somewhere. Oh, here. Yeah. So first of all, you have this rule delayed thing. So that tells wolfram language, you are creating a rule, a delayed rule. Then it takes 2 arguments. The first argument and the second argument. The first argument says it's a pattern, okay? It's a F something, then pattern. Pattern is a blank, that means anything. Then this pattern is named X, okay? Basically, you are telling wolfram language to replace that whenever it sees that, replaced by that. So that's how it works. So I think that's it for today. Thank you guys for watching. Yeah, I think that's it for today. Any questions? Any questions? Let's see how many people are watching. 11 people. Okay, if you like my stuff, donate. Go to my website, any of my website, XahTV.info, XahTV.info. Then you can see. Just put money in my pocket, support my YouTube channel and stuff. You can Patreon me, Amazon gift card or PayPal, or you can buy my tutorials on Emacs, Emacs, or JavaScript in depth. So I have a bunch of lots of tutorials on programming languages. Anything else? Any questions? Okay, so that's it. We're gonna shut down in 2 or 3 minutes. I'm shutting down in 2 or 3 minutes. Now I'm just going to do cleanup. Let's see. So I'm going to finish this tutorial offline. Finish types of stuff we talked about. A very basic tutorial. So we talked about list. We talked about nested list. We have nested list. We have list operations, all important. Then we talk about functions. Then we started to talk about the pattern matching and rewrite systems. So what's the relation between pattern matching and rewrite systems? Well, the relation is that when you have a rewriting system of a programming language, you need pattern matching for it to work. Essentially, yeah, just like regular expression. How do you, if you have a regular expression, if you want to do string replacement, you need find and replace, and one of the mechanism is regular expression. So, or you could say it's a pattern matching, regular expression patterns, pattern matching. So you need pattern matching to do string replacement, find and replace, such as in Microsoft Word. Okay, you need pattern matching to do string replacement, and regular expression is one of the standard way. In the same way, you need pattern matching to do rewriting system. Now, the context here is different from string replacement, find replacement, because when you have a rewriting system, a general rewriting system, you are dealing with source code, not just strings, but your source code. So there are many types. You can do symbolic pattern matching rewriting system, such as wolfram language or Haskell or Camel. They have value and type based pattern matching. So that's the relation, of pattern matching and rewrite systems. Very interesting. Okay, you should read, because rewriting system, then it gets onto formal logic. Then it gets onto the heart of mathematics, the foundation of mathematics, proof systems. You see, theorem provers, and so on. It's quite interesting, fascinating that how the simple idea of string replacement is actually the foundation of mathematics. Yes. Okay. Bye, guys. Yeah, I think what else I covered wolfram language. I think that covered all. So you can start to program wolfram language now. And last thing, by the way, wolfram language is free. So you go to my website, just search for XahTV wolfram language. Then there are 2 videos. There are 5 videos I did before. You should go watch them. They are all about wolfram language. Then you go to download wolfram language for free. So you can either get it cheaply or get it for free. But I recommend you just buy it, because you have more benefits. By the way, you don't get crippled version. Whatever you get is the full version. Essentially, they are not like every 5 minutes they're gonna pop up. Oh, you need to pay. Remember to pay. Nothing like that, or disable some features. But I think anyway, you get the wolfram script or wolfram engine. I think by default they don't allow graphics, I think. So you cannot have 3-dimensional rotation of 3-dimensional geometric objects. But if you also download the Python, that copy of wolfram language notebooks, then you can get that to work. Yeah, but just buy it, okay? That's it. Bye, guys.